The 360 on Energy and Carbon, hosted by 360 Energy. As President and CEO of Essex Power, John Avdoulos leads a team that is committed to innovation, technology, and strong performance management. Through innovative technologies, the Essex Power group of companies has successfully built the foundation to establish a diverse set of energy products and services that provide value to its customers. Essex Power is a dynamic energy company that continues to build solutions for the future. Previously, John was the COO for Essex Power Corporation. John joined the energy industry in 2006 and has been able to transfer valuable lessons learned from his previous experience in the manufacturing sector. John's past experience provides a unique view to the energy industry, as John has already experienced many of the changes that the energy world is currently seeing. John holds a board of directors position at the Electricity Distributors Association. John holds an MBA degree from the University of Windsor, a Bachelor of Science degree in Engineering from the Lawrence Tech University, a Bachelor's of Art degree from the University of Windsor, and a McLaughlin Master's Certificate in Project Management. John obtained the Chartered Director designation from the Directors College in 2022. He is also a member of the Association of Energy Engineers. Now let's get into the episode with John. Welcome, both of you.
Thank you, Lysandra. And John, I'm so glad you're back to continue our discussion.
Yeah, thank you for having me. I enjoyed our chat last week, and obviously there's lots more to chat about.
In our previous episode, we talked about the future of utilities, which requires a great deal of innovation in the space. Where do you see growth in the electric utility space?
The electric utility space, I don't know if I'd necessarily call it growth, but transformation is something that I definitely see. We've adopted a saying where utilities are transforming from poles and wires to energy management services enablement companies. And essentially what that means is they're no longer a unidirectional deliverer of electricity where you're just maintaining assets for one-way flow. They're going to have to adapt to enable multi-directional flow of electrons and essentially unlock the ability for consumers to have more choice through adaptive infrastructure and power system flexibility, and enable any idled assets that might be sitting out there that specifically on the generation side that could provide an ancillary service to the distribution system. We know that we can't continue to invest as much as we do to meet the needs of the economic growth and technological change that's being undertaken. So utilities need to transform to say we can use those assets smarter, we can extend the benefit of those assets, but then we can also allow for other resources or distributed resources to connect and provide potential benefit back to the system, and then also provide an ancillary benefit to that asset owner where they can monetize maybe something that's sitting there idle and not being used for anything other than a potential emergency situation, and get a benefit from themselves, but then also benefit the distribution system. So I don't necessarily know that utilities are going to be able to grow into different companies, but I think they have to transform into something.
John, every day you hear something about the electric vehicles, whether it's through manufacturers. We work with a large automotive facility, and they're talking about what they're doing for electric vehicles. That's got to have an impact on the utility industry. So what do you see?
Yeah, so that's very interesting. And we've done some analysis specifically to the Essex Power Lines distribution system with the current state. And it highlighted a few major issues. One is that utilities don't have visibility into where electric vehicles are installed or electric vehicle charging systems are being installed. And that could have a negative effect if we at one point have 3 or 4 electric vehicles all charging at the same time and they're all connected to the same transformer. That's going to have a negative effect. That'll cause a failure for sure. And that ultimately would increase costs, cause outages, and disrupt service. So that's very impactful. And when we looked at what does full electric vehicle adoption look like to our system, we said there's a way to manage it if we had visibility to all electric vehicles and where they're being deployed in our distribution system. And that's just the one part of it. So we actually did approach the IESO, raised this, and the IESO did fund a project with one of our other subsidiaries, Essex Energy, that specializes in energy hardware, where we were able to use just meter data to run a machine learning algorithm on the distribution system to be able to help us identify where vehicles are charging and when, so that we can potentially start creating a strategy to manage electric vehicles and when they charge. Now, that's going to take some requirement to have industry and government make an alignment between the automotive manufacturers, that they might need to have the ability to receive a signal to say that maybe now is not the right time, and we need to either level you off or turn you off so that you're not going to negatively impact the system. So from that perspective, it's manageable if there's some things that can be taken into account, like providing better visibility, like ensuring that there are standards in place that could potentially enable a vehicle or a vehicle charger to receive a signal. On the other side of it, there will be some shoring up required, because electric vehicles are just one of the many additional assets that are going to be deployed to the distribution system that's going to require an increase in the type of infrastructure to handle the electron flow. So hopefully that gives you a little bit of a view of where Essex Power Lines is focused on. First of all, we need visibility. And again, our assessment is that we could manage if we knew where all of the EVs were being deployed. And at some point, there will be a further investment, but it's going to be as a result of understanding the full magnitude of assets that are coming on to the electrified platform.
I think everyone thinks of electrification of cars, but some of the work that we've been involved with the University of Windsor, and it's still early, but just for truck, heavy transport, we're looking at a peak load, if there was 100% adoption, of up to 8,000 megawatt peak demand in the province of Ontario. That's currently 1/3 of the province's demand. That's massive. And not only do you have to have that generation in place, but as you just described, you have to have the infrastructure in place to ensure that you can actually do that and when you can do it. So it's a big undertaking. And when you talked about the signal, I'm old enough to remember when hot water heaters, there was a plan where you could turn and turn off hot water heaters just based on market pricing or demand. So I can see that happening. I mean, it's been done in the past with the vehicle. So that's quite interesting.
Yeah.
Next question. In Canada, and every jurisdiction is different, but some jurisdictions are looking at increasing electrical generation, which would mean also electrical infrastructure, by sometimes threefold. I know in Ontario, the province that we're in, they're talking about a 38 or 43% increase in electrical generation. That's big, and because I know how long it takes to get that in place, but I think there's ways of doing it, certainly generation at the grid, but also distributed energy resources. So how do you see how distributed energy resources will be impacting you as an electric utility? Because that adds a dynamic that you've kind of described as well. How do you react to that?
Yeah, so that excites us because there's no single solution that's going to solve the problem. It's going to have to be multiple layers and multi-pronged, and it's going to have to be supported at multiple levels of government as well, federal, provincial, regional, and local. But that excites us because we can be part of the solution, and we have to be part of the solution, because again, trying to increase the generation capacity by 30 to 40% is not going to be done by one technology or one plant. So the way we look at distributed energy resources is that this is going to be a major part of the solution. So to start off with, we have, and being from the greenhouse capital of North America, down in the Leamington area as well, we have a considerable amount of greenhouses that have generators, and they're not tiny. These are 10, 20 megawatt generators that they've secured for energy stability on their operations, that maybe only operate 10, 15% of the time and are a cost center to them. But if you look at 200, 300 greenhouses that potentially have 10 megawatts each of potential dispatchable and manageable distributed energy resources. That's pretty significant in our area where we're already experiencing a supply crunch as it is. And there's tremendous amount of investment that Hydro One is undertaking to bring new lines down to our area and build new transformer stations. But even then, it's probably not going to be enough. So when you look at the potential existing capacity of connecting 200 generators at 10 megawatts, that's 2,000 megawatts that could be a significant help to the distribution system. And then you take into account, maybe if you look at in our area, we have 150,000 customers across Windsor, Essex, across all the local distribution companies. Maybe if we had an adoption of 10,000 of those that were able to put 3, 4, 5 kilowatt solar panels on there, that's a huge benefit. And then you take into account on the potential for EVs to be an answer as a distributed resource. And if you're going to have 100% that are takers of power, but then can also be givers of power, then there's a major resource. And you combine that with other efforts that are going to be undertaken to build either small nuclear reactors or whatever other new hydrogen technologies or renewable natural gas technologies that maybe we don't even know about today that could potentially be a part of the answer. We're excited because we need to be part of that solution.
And for our listeners, the electrical grids around the world were typically set up to go one way, where there's generation and it was sent through the lines and it was to the sites. What John is describing with the distributed energy resources, this power is going to go not only to clients, but clients are also going to send power into the system. So it's a whole different type of control system and thought process that needs to be, it's a game changer, and it will require different thinking. So it is exciting, John, I do agree. Staying with that and staying with electrification, decarbonization, I have a colleague that actually bought for his home a heat pump. I'm like, wow, you're already on this. So, and I see, this becoming bigger and bigger with sort of phasing out some of the fossil fuels as we go forward. Is the adoption of heat pumps, like, how big of a possibility? And if so, do you see it impacting the electric utilities as well?
It definitely has a potential to impact electric utilities. I believe the adoption of heat pumps right now is dependent on the cost of moving to an electric heat pump, and B, the cost of gas as it relates to assessing the cost of moving to an electric heat pump. So when we saw natural gas spike, there was a lot of interest in people trying to get off gas and figure out what they could do to conserve or save. And electric heat pumps would definitely be a lot more efficient and economical in the long run, and assuming gas prices stay high. So that's a variable. But then the cost of transitioning from natural gas to electric is sometimes looked at as very scary by the consumer. And I know the federal government has a program right now where they're subsidizing, the transition from gas to electric heating. And that's good. And eventually, I do believe that the migration will continue. There will be more adoption and the costs will come down, which will help. So, but the impact then is that it's another device that's going to be putting a strain on the system. So the electric heat pumps, they do pull a good load and they are very efficient, but it's an added constraint to the system in terms of, can the network handle it? Can the transformer handle it? And it's not only on a one-on-one basis between one heat pump to the transformer. It's the fact that you have 10 or 15 customers all on the same transformer, and the heat pump is just one other added device that is going from gas to electric. And we also hear about potential gas stoves being transitioned out and only electric as well. So there's another one. Gas pool heaters, so those would be transition. So it's the aggregation of those plus EVs, which we know are all stressors that are coming our way. So that's probably one of the biggest net effects to the electric utility. But is it the right thing to do? Yeah, it is.
Yeah, so I kind of hear, all these lower carbon emission technologies like stoves, heat pumps, electric vehicles, some distributed energy resources, like if we're talking solar or batteries, are being adopted by consumers. And again, these are lower carbon emission technologies. But Do we see net zero carbon emissions as an opportunity for electric utilities to also adopt?
Yeah, definitely. So we know that there's a potential for green credits or carbon trading. So utilities, again, with demand response programs or with the adoption of non-emitting resources, if they can quantify the net zero or the carbon reduction, they should get credit for that as well. That's something that has been dabbled with in the past. The IESO was the receiver of those credits when the FIT program and the microfit program was launched, where the credits went to the IESO and they've accumulated those. The utilities, electric utilities, could have the same opportunity to potentially monetize those credits. And that could be one way to pay for some of the investments that are needed as well. So that's on a very rudimentary way a utility can take the opportunity from net zero non-emitting resources being deployed in their system and getting credit for it.
John, just picking up, I read this week one of the large utility that you would be familiar with actually is getting green bonds through a financial institution to invest in their infrastructure, being able to demonstrate that there is emission reduction. So it seems to me that's kind of the future of where this is going to go. And that's where I think utilities will need to perhaps consider financing going forward as well.
Absolutely. Definitely an opportunity.
So John, you touched a little bit about it, but can you tell us about your project with the ISO and the OEB? And to be was there one project? Was there many projects? To be clear, I'm not sure what that is, but if you could describe to our audience what that project was.
Yeah, so our project with the ISO and the OEB is I'll call a first of a kind. I know that I might offend some people in other jurisdictions, but I'll explain why I call it a first of a kind. It's located currently in the Leamington area of Essex County, where we do have a lot of constraints. There's a tremendous amount of greenhouse growth and manufacturing growth down in the Leamington area. And we put up our hand and said, there's an opportunity to connect these distributed energy resources, but there's really no construct or avenue or framework to allow utilities to be what we call a DSO, a distribution system operator. So this talks to our philosophy that utilities are no longer going to be poles and wires companies. They're going to be energy management services enablement companies. And the distribution system operator is essentially a mini ISO in the region that operates at a local level that can take these distributed resources and allow them to be bid onto an open market and get dispatched and compensated for, and then provide an overall ancillary benefit to the entire region. So we're a mini ISO and we're going to be integrated into the IESO, which is the bulk ISO system. So that's why I call this a first of a kind, where we're going to have an actual open market. And I know it's considered a pilot, but from our perspective, this isn't a pilot. It's going to be a transformation where this is the first step and it's just going to grow from here. So by definition, a distribution system operator is not bound by a service territory line. It's essentially a regional benefit where electrons can flow bidirectionally. To your point earlier about the connection of DERs are no longer going to be one-way flow. So we're going to manage the flow of electrons. We're going to have to ensure the visibility to the distribution system provides us any risks that are potentially going to cause failures. We need to manage the technical side. I don't think that that's going to be an issue in any way, but it's the market side that is interesting as well, because again, now you're creating a mini market for small players that might own a 500 kilowatt generator or a 1 megawatt generator, and or even a 10 megawatt generator. Now they get to do something with that asset. So the ISO and the OEB have been extremely collaborative partners on this project. Our team's been working on it for 6 months. We do believe it's game changing for the industry. It's proving out how do utilities transform and allow for connectivity of these distributed energy resources and ensure that there's a fair playing field, that they get to bid in on an open and transparent market. They get to see the day ahead pricing. They get to put in their bid, and if they're successful, they get dispatched and they get paid. So that's all, like, for us, very cool to be a part of. And the one aspect that, we talked about on last week's episode was the OEB and what role they're going to play. And they have a vested interest in trying to understand how can they ensure that ratepayers are protected by this. So utilities migrating into a DSO platform are going to have to figure out how to allow the connection on the technical side, and figure out also how do they ensure that the market is treated fairly and that ratepayers are not being unfairly paying for some of these electrons. So it's a really unique project. I believe we're blazing a trail. Again, first time that an integrated market is being it's the first time an integrated market is actually being deployed in North America. There are some jurisdictions in Europe that we're benchmarking to understand how they're handling it, because they also are going through this transformation as well. This is not a local issue. This is not a North American issue. This is done globally. So for us, it's going to be, very exciting to be a part of leading that transformation.
John, I would just want to comment. I actually think it's the future. I totally agree. We're on board and think this is the way it's going to go to make things happen. So congratulations to you and your team thinking out that way.
Yeah, thank you. You mentioned it earlier in terms of, again, the generation supply crunch. And DERs, they have to be part of the solution. Utilities have to be that point of common coupling to enable the connection of DERs. But the DSO aspect of this is how you can make sure that technically it becomes standardized somehow and integrated to the IESO system. And then on the market side, that it's fair, open, and transparent.
Yep.
Well, this episode highlighted many diverse opportunities for utilities to innovate. What is the biggest takeaway for our listeners from this episode?
Yeah, so for this one, last week I said it was awareness. This one, it's opportunity. We touched on EVs, heat pumps, stoves, all transitioning to electricity. That means that there's opportunity for everyone to contribute to the solution as well. So it's not only a one organization or one industry problem. This is a global issue. And all listeners are part of that solution, up to and including a resident that might be able to transition from gas to electric heat pump. That's helpful. And then up to and including the government, where they have to figure out how to create linkage and synchronize between all of these efforts to make sure that there's a unified strategy. So that's the opportunity that I think is the biggest takeaway now.
Dave, what was your biggest takeaway?
I'm in total agreement with John. It's a massive opportunity, but a customer perspective, and that is the customer is really going to have to understand their usage, what uses what, when do they use it, to figure out how to go forward and working in cooperation with the utilities or their suppliers. That would be a must. And to be fair, our experience, most customers they don't have that total awareness of energy usage. They'll get their bill and pay it and not have that. So they're going to have that knowledge going forward.
Yeah, I think what's interesting is each community is so different in the way the utility operates, the type of electricity we receive, the type of generation we're going to have. So with studies like the one you're doing with the ISO and OEB, I'm sure these studies are happening all over the world. And I'm really intrigued to see what the outcomes are going to be and how communities are going to differ, especially, neighboring communities may operate totally different. So it'll be really interesting to see. And I think that's just the beauty of the innovation in the utility space in these next couple of years.
Definitely agree.
All right. Well, thank you both for your time today and have a great week.
Thanks, Lysandra. And John, I thought it was fascinating. Thank you for joining us. Appreciate it.
I appreciate you guys having me, and I hope you guys have a good week as well.
Thank you so much.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn post. See you next week.